If you don't know me, I'm Matt Reisinger, the usual host of the Build Show, but today it is the Build Show webinar. We are here with some friends from Stego Industries. First off, let me introduce Bret. Bret's the director of marketing for the entire Stego Industries, but Tom is my man on the residential side. Tom specializes on all these products we're talking. This is a webinar intended for houses, but of course, I've been using Stego products for a long time, and one of the things I like about these guys is when I knew them back in the day, 20 years ago now, I only knew them as these bomber commercial products. These are the same DNA as we've seen on my job sites with some different flavors, really intended for the residential market. So, gentlemen, how you feeling? You ready?
Yeah, happy to be here.
Yeah. All right, good deal. Hey, for anybody who is watching live, if you've got a question for us, hit that Q&A tab and you can send your question to us. We'll make sure we leave some time at the end for Q&A. If you're watching this later that's been recorded, make sure you sign up for our newsletter. There'll be a link in the description below for newsletter so that you can go ahead and sign up for these live events. With that being said, let's jump right into the presentation, Tom, shall we?
Yeah, let's do it.
Why does a vapor barrier matter, Tom?
Well, a vapor barrier obviously is needed to help impede the movement of water vapor. In our case, and what we spend our days talking about and educating the industry on, is helping isolate homes and buildings from soil threats. Water vapor being a big and common and ubiquitous threat or issue.
Yep.
But there's other things in the ground too that can cause problems.
For
Anything from soil gases like radon is a big one in the residential world. Even man-made chemicals like VOCs can be a problem on some projects. Termites too. Subterranean termites can be a big problem, especially in certain climates. And no matter the project type or the foundation design, keeping those things out from the first side of the home is really important.
So in the webinar today, Tom, we're going to spend a fair amount of time running through all those conditions, even some that aren't typical for residential. Like, what if you've got a brownfield site and you need to keep all that nastiness out of the soil from coming into your building? We kind of think of this as the sixth wall, so to speak, on the house. And if you've been watching the Build Show for any length of time, you know that we're really cautious about the other five walls, the fifth being the roof. So this webinar, we're going to dig into a bunch of details on what's typically done in the industry, what are some solutions from Stego, and why is this different than some of the other options out there. But before we do that, Tom, will you come help be my Vanna White for something? I want to do a little display that I was playing with here at the shop. I think as builders, sometimes we think that our concrete is impervious, right? I remember as a young builder, the very first time I dealt with a foundation leak, and it was kind of this like, oh my gosh, I can't believe this massive wall of concrete has something coming through it that I don't want inside my space. So what I've got here is just a quick demo to show us how porous concrete is. I'm gonna turn my camera on here. In this pan is just some dyed water. There's nothing special here, just some blue dye so you can see the water. And Tom's got in his hand over here just a regular old paver that we got at the home center. Inch thick concrete, right? Just a regular concrete paver. And Tom, if you would drop that slowly into the pan of water, you're gonna notice that it's just barely on the bottom side touching. And look how quickly that water wicks up on this dry paver. It's crazy how quickly these sides got wet. So right here is the water line, and look at that water coming all the way up. So much so that, look, even the top of this paver, what is this, like 30 seconds later, Tom? Yeah. Is getting totally soaked. Now, I know your product is not intended, Tom, to be a water barrier, but how does this quick demo relate to the need for a vapor barrier?
Well, probably the biggest thing is if we see the porosity of concrete here, then you know vapor's getting through it as well. It's not vapor proof.
Yeah.
And it's not like products like ours installed well can't be a capillary break for the rising damp. Bulk water, hydrostatic pressure, a little bit different animal, different evaluation, different even solutions potentially.
Yeah.
But this is really getting into some of the things we'll talk about of the way vapor moves. It's also just proving that in the ground there's moisture.
Yep.
Whether it's a foot below the ground as the water table or 500 feet.
Yeah.
There's still moisture in the ground, and
There's
it's
still
always
moisture.
moving in one direction.
Even in dry climates.
At least in vapor form, for sure.
Yeah, that's right. Now, Tom, I've got one more demo that takes a little bit longer to show, but if you'd be my Vanna White here and do this, here's what I've got. I've got Tom holding two demo pieces for us. This is a CMU brick, basically, just full concrete, solid concrete. And this is just your standard SPF, spruce, pine, fir, 2x4. Drop those into that water. And we're gonna see at the end of the demo, see if you can kind of get those to stand. You might put this one in first. See if you can get those to stand up as straight as possible. Maybe lean them against each other in a tent format. There you go. And we're gonna come back at the end of our time and see how quickly and how differently these two wick water. Because we all know as builders how much moisture wicks through that tree, up through the tree roots. But I'm curious to see if we can show, oh my gosh, I gotta show you on the camera, hang on. Even in this short couple seconds, you can already see that the 2x4 and the concrete are wicking. And again, look at that, totally soaked now, 100% wet all the way to the surface. So much so that I can even feel, you can see the moisture on my hand from that. That's crazy. I like that demo, it really shows it, Tom. All right, let's go back to the slideshow, shall we? Turn my camera off. Again, if you're watching this live and you've got a question for us, don't use the chat feature. We're not using chat. Everything you want to ask us is going to be on the Q&A tab. All right, Tom, walk us through some of the options and some of the things we're going to talk about today with Stego.
Yeah, I mean, we like to think that no matter what you got, if you've got a home with a crawl space or basement or slab on grade, no matter what the size is, we've got a solution, or even the soil threat for that matter. Again, a lot of what we've carved out 30 years doing is water vapor protection. A lot of people know Stego from our yellow Stego wrap.
Yep.
Commercial vapor barrier that's been used for a long time. But like you said at the beginning, we think we've got, you know, an option that fits any situation.
Yeah, for sure.
Including StegoCrawl, which is what you see in the top left picture there.
That's that white one right there.
Yeah, aesthetically nice, and crawl spaces, comes in different sizes and thicknesses, depending on performance and budget needs, and just ease of installation. The bottom left is a green StegoHome. We'll talk more about that, but
it's like an ICF foundation, and that's going over top of the maybe the insulation layer before that basement slab gets poured.
Exactly, in that photo there. And then we've got some unique systems as well. Pango is our 2-in-1 moisture vapor and termite barrier, and we're also showing a system called Drago, which is a pretty robust material, but it's designed for contaminated sites, VOC situations.
So if you've got a brownfield site, like I mentioned earlier, that's your barrier from that coming up through the...
that's your vapor intrusion barrier.
Yeah, that's a big deal.
Different animal, yeah.
That's when you need something a little more robust, right?
Typically, yeah.
Well, all these different foundation types and different barriers, it's not just the selection of the barrier also. So we get into the detailing later on as we look at different accessories that are needed.
Which I think really sets you guys apart from the rest of the competition. Your accessories are bomber. And I remember the very first time I used Stego tape and was like, wow, this is incredible. So we're gonna talk about that in a minute. Okay, so moving on, now we've got a more typical slab on grade. In fact, I think this is one of Jake Bruton's projects in Missouri or probably Kansas City where he builds. What are we looking at here?
Yeah, slab on grade with a thickened edge. This picture is just nice because it shows the concrete being placed over it. And really, you know, one of the things that we'll dig into, and I think this is where we see an opportunity to keep educating the industry, you know, by and large on a wide scale, is really the difference between high performance engineered vapor barriers in this application, whether it's below a slab or in a crawl space, versus, frankly, what's very common in the residential landscape.
Oh man, this picture could be taken anywhere in Texas. This is pretty common throughout there in Texas, and I suspect a lot of the South. This is just some clear 6 mil poly, isn't it?
Yeah, or black poly like this. You know, that's the norm. That's checking a code box in a lot of jurisdictions. You know, a lot of people might think between poly and Stego, it's just plastic, right? And that's a misconception. That's a myth to be busted. There is a lot of, there's a difference between engineered films, engineered vapor barriers specifically for these applications, and recycled low quality commodity plastic that gets used and we'll talk about can lead to some concerns and ultimately some problems for builders and homeowners.
Yeah, we're gonna get into some of those details in a minute, but I wanna specifically mention another detail I see all the time, and that's this image right here. Throughout Texas, through the years, I've seen this more times than I can count, where there's some amount of poly used at the tops of the grade beams, but the bottom of the grade beam has been removed for whatever reason. The concrete guy saying, oh, the concrete's got to bond with the soil, or who knows what. So I made a little bit of a demo because I was curious to see what that same demo that Tom and I did earlier would look like if we kind of mimic this. So in this photo you're seeing the poly that's in the center section where the slab's only going to be, let's say, 4 or 5 inches thick, but the poly has been cut out of the beam area, which would be the deeper concrete. So I took that same concrete paver, I used some fluid applied that will actually adhere to the concrete and will waterproof it. And we did here's my GoPro of that happening. So this is the same paver that you're about to see dropped into that blue tub again. And look how it absorbs straight through. And you can kind of see that square, just like you see in Bret's hand here, where the moisture comes up. And look at my timer. 2 minutes and 30 seconds later, roughly, maybe call it 3 minutes later, the entire thing is totally wet, right? It just shows the power of that concrete wicking that moisture. And just because you've got it just in the beams there doesn't mean that moisture is not going to go everywhere. It just that detail is one that absolutely drives me bananas here in Texas.
So you look at the time in which it comes through, and let's say you have a 36-inch interior footing.
Right.
You think, oh, it's not going to move through because it's so thick, or it's so dense based on the mix design. But as you can see from this, it's porous, moisture moves through, and especially in a gaseous state.
Yeah, so this is maybe an inch thick paver, and it took, let's call it 3 minutes to soak the whole paver. How long does your house need to resist that water? Will 3 minutes times 36-inch deep beam mean that you're fine? I don't think so. No, I don't think so. The other problem that we see a lot is just really bad crawl spaces. This is your photo, not mine. We're about to show some of mine, but this is throughout the whole U.S., especially in the South and the Northwest. I would say we see a lot more crawl spaces, but just absolutely disgusting spaces. No real thought to the vapor barrier. It looks like that might have been a clear poly at one point. It looks a little yellowed with time, but clearly dirt showing, insulation falling down. This is probably a ventilated crawl space. And Tom, here's one of my photos from my archives. When I spent a couple years working in the Pacific Northwest and I first moved there, we did nothing but vented crawl spaces. And we just used some loose laid black poly. I don't know if it was 6 mil, but probably. And man, you'd go down in those crawl spaces and they were absolutely disgusting. It was a mold fest. It smelled bad. There was usually some amount of standing water somewhere in the crawl space. It was disgusting.
Yeah. Yeah, I mean, no matter what you got, I think what we're ultimately going to get into is this can be a building envelope component that needs a little more attention potentially. Yeah. And a little bit of a mindset shift in the industry from throw down, frankly, the cheapest commodity, whatever our trades want to do that day, to no, we're isolating the home from real threats that have real impacts, and we can take this, thoughtful, educated approach to our barrier selection.
Yeah, and frankly, this is a part of the house you get one chance to do it right? I mean, you might rip that kitchen out in 20 years because it's outdated. You are not remodeling your vapor barrier and pulling your slab out because you found a moisture problem. It's just not going to happen. So by doing this right from the start, we're setting that house up for a lifetime of success, right?
And in some ways, and we may not get in the weeds today, but controlling vapor at the first site of the home and the evaluation and the selection of an effective vapor barrier is pretty simple when you think about it, especially when you compare it to evaluating a vapor barrier, a vapor control layer in other parts of the envelope, where a vapor barrier might be a bad word in a wall in a lot of cases because it's in the wrong spot, or it has too low of permeance, things like that. But as we'll talk about, the first side of the home, as long as we get a few main details right about the performance of the material, it's pretty straightforward.
Yeah.
Well, and it's not just about doing it right because you can't go back and change it. It's also all the disruptions that happen and the impacts that happen downstream for that homeowner or those occupants. So.
That's right. Talk me through this, Tom.
So this is just kind of giving a rundown of how water vapor moves here at the first side of the home. Like we showed in the example, we kind of talked about, there's always moisture in the ground beneath a new home build. And whether it's liquid water in the water table at some depth, heck, you might have situations where it's very close, but even if it's low, the water table is low, and the soil may seem dry, or the geotech report didn't really find anything too concerning, we still have to understand that there's the movement of water vapor via diffusion that's happening. And this is just natural earth science. It moves from more to less.
Yep.
And again, kind of unlike above grade wall systems, it's moving in one direction all the time, right? It wants to go from the ground into the home. And because the concrete is porous and not vapor proof, it can continue on until it meets sort of the next layer of the assembly, which we'll talk about, sometimes can be a sensitive flooring material.
Yeah, we're going to show some of those issues in a minute, but you know, if you think about that moisture going from more to less, if it hits a barrier or something that stops it, condensation's going to happen, moisture buildup's going to happen, and we're going to show you some of those problems in just a second here.
This is just an industry quote, one of many that explains essentially, again, regardless of climate zone, water table depth, if you don't actually have water saturation in the soil, you at least have vapor.
Yeah.
And it doesn't take long after a concrete slab is cast on the ground for that water vapor to be added close to 100% beneath the slab. So you've created this pressure, this drive of diffusion that again is very strong and moving in one direction. And very different than, again, how we would think about vapor movement in your above grade wall assembly in a lot of cases.
Yeah, that quote's really cool. 100% relative humidity directly below the slab.
Yeah.
And we can actually show that in these photos. And I've got some photos from my job site just like this, where if you can kind of picture somebody touching that Stego right there, that's actually liquid water that's condensed on the bottom side of your vapor barrier because it's 100% relative humidity down there. And so it's condensing, but it's not moving up to the surface beyond that.
Yeah.
And if you think about it in high humidity, not even 100%, if it's just high humidity, but then temperature change, that dew point phase change happens and you have condensation that can cause all sorts of issues.
Yeah, big time.
Now, if you did not have a low permeance, effective, properly installed vapor barrier beneath the slab, then again, what's the next layer of the assembly it hits?
This is where the problems come in.
It could very well be a resilient, impermeable flooring material, or just a sensitive flooring material. And so you think about the wall, just analogy again, it's like now having a vapor barrier on the wrong side of the slab.
Not good.
Not good. So now you've created your condensation point and the dew point at your flooring system. And
what are we seeing in those two photos? Walk us through those.
So on the left is an example of a re-emulsified broken down adhesive. I mean, one of the things that really drove the need in the industry for high performance, low permeance membranes like this beneath the slab is the switch to water-based flooring adhesives.
Interesting.
Decades ago, they were solvent-based, very robust. They could withstand some moisture. EPA changed that. Water-based adhesives work great as long as the slab stays dry. And so that, and then on the right is an example of some basically dew point in a more of a wood floor system of some sort. And that was actually a project in Phoenix, Arizona. Well, probably the driest place you could think. And they're having the same kind of problems that people might expect to see in more.
That looks to me
moist
like
climates.
there was actually condensation, that when you stepped on that hardwood plank, there might have actually been liquid water coming out from the condensation.
That's what the homeowner reported. And it led to issue with the builder in that case. And, you know, I mean, there could be other sources of moisture, but that's an example of a situation where the diagnosis was, well, there's no vapor barrier beneath the slab.
Yep.
And the builder probably said, well, of course, I'm in Phoenix. And we see some of the biggest problems in dry climates because of water vapor movement, accumulation, condensation, and reintroduced water that can cause problems.
Those things don't just happen in Phoenix either, do they, Tom?
Did you want to say something, Brett?
Well, I was going to ask Matt, when it comes to impact on a builder, you know, you can do everything right, but even getting called back and having the questions is a disruption in business. And so I'm just thinking about what you're trying to deliver to your clients.
Yeah, I mean, let me back up a quick second, Brett, and say, you know, a big part of me starting the Build Show to begin with, I started making my first YouTube videos in 2008. I blogged for a year prior to that, was because I went through, in the early 2000s, multiple lawsuits for a builder I was working for that the long and short of them was every time we got sued, it was water related. And so I started digging into this new thing I'd never heard of as a young builder called building science. You know, how does the physics of buildings, how does water affect our buildings? And what I found in that young part of my career was that 80% of construction defect litigation is water related. And what I cared most about was preventing problems, preventing lawsuits. You know, a lot of what I talk about today on the Build Show is not because I want to save people energy or I want to have the lowest energy bills, but I really want to make sure we're building houses that are healthy, houses that aren't a lawsuit and a problem for the builder like I had to endure for all those years. And I don't want you to deal with homeowners that feel like, hey, this is really affecting my health or my family's health. And so these buckled hardwood photos you're seeing here are from that. Here's another one that's really close to home. Here in Austin, on the nightly news, our local KXAN station, there's a subdivision that's facing a slab moisture lawsuit to the builder. And I found this video on social that is really scary, frankly. And pull that up one more time. As you look at this person going through their house and looking at their hardwoods that have problems, you can almost see the darker areas on the hardwoods, which are moisture issues, look to me like they are beam sections where they land on walls that probably have a bearing space on them. And I'd be willing to bet, and I don't know this for sure, but that the moisture issues that this person is experiencing, and this builder basically has a class action lawsuit, those probably are related to what you're seeing there. I'd be willing to bet that this builder built with standard poly, let's call it that, 6 mil poly. They cut out the beams where the at the bottom of the beam depth, so there's no moisture, there's no vapor barrier there whatsoever, not even 6 mil poly. They were laissez-faire in their detailing, and then that we saw Bret pull up is happening. And so this is a class action lawsuit. So for me as a builder to take the time to do it right in an area that I cannot go back and remodel and fix later makes all the difference. So as we get into this later, we're going to talk price, we're going to give you frankly a lot of good ammunition so that if you've got a concrete sub that pushes back on this, if you've got a homeowner who says, oh, we can do it cheaper if we do this, we really need the ammo to say, hey, we really need to do this right, and it's worth paying more than the standard practice, which is a terrible standard practice.
Yeah.
Yeah, that pennies per square foot investment in the front end can save you that headache and heartache later on.
That's right, and your reputation and all that. Talk to us a little bit about mold too, and I hate to tell you, but that homeowner that made that video also has several other videos about this topic.
Yeah, I mean, it's not just damaged flooring and the headache and the cost, but it's human health concerns as well. Moisture from the ground in any form, and even as water vapor, can lead to an environment that contributes to potential mold growth. And it needs a few things. It needs food source, it needs temperature, but moisture is the thing we can really control and keep out of the home from the beginning. And it's, again, not just under slab, but a big issue in crawl spaces. And not just moisture from the ground, obviously, the big issue with vented crawl spaces and just moisture moving in through the moist, humid air that's coming into crawl spaces in certain climates. But from the ground as well can lead to all sorts of concerns in crawl spaces that we deal with.
That's right, for sure.
The tough part about mold too in the industry is insurance companies aren't typically covering mold.
They stopped covering it in 2001, which was when I was dealing with it, and they were covering it back then, and we had lots of problems. But insurance companies in about 2002 or so stopped covering for mold. And so as a result, most of those lawsuits went away. There wasn't money for it anymore. But I would tell you that there's a resurgence in that today because people really understand the health effects. And if you've got a homeowner that can hire a lawyer, there's a firm right here in Central Texas that specializes in this issue right here and suing builders for it. So it's not a matter of if, it's when. If you're building shoddy houses, it's going to come back to bite you.
Yeah. I don't think we want to go into too much detail on vented versus unvented condition crawl spaces. We can if you want, but I think I'll just make the point. I was going to make, real quick, the point about the building science, of course, would suggest there's a lot of benefits.
Yes.
Efficiency and structural integrity and long-term performance and durability with unvented conditioned crawl spaces. And in our realm, it also raises the stakes on the performance and the installation of a quality vapor barrier. Because, you're at that point, because your crawl space is now a little bit more like the rest of the home and conditioned.
It's a short basement, is where it should be.
You got to take the ground into play. And,
That's right.
So it raises the stakes on the performance of the membrane.
Yeah, that's right. Let's keep going.
Okay. Probably one of the biggest concerns that we get asked about, soil concerns, and maybe one of the biggest drivers for builders and homeowners is radon gas. The movement of radon gas into the home can have a real impact on human health. Second leading cause of lung cancer behind cigarette smoking in the US. Can affect any home, really, but especially homes that may fall into the EPA's higher zones for radon potential.
So how does Stego mitigate that radon issue? Or what do you guys do to help mitigate that?
Well, it acts as the soil gas retarder.
Okay.
It's part of the system. If you look at industry code language and standards for radon mitigation, like from ARST, got to at least start as a passive system.
Mm-hmm.
So it includes a gas permeable layer, crushed rock, or a soil gas collection mat beneath the slab and beneath the membrane, a vapor barrier, a soil gas retarder is the next piece of the puzzle, installed beneath the concrete slab, and then a pipe, vent system, either relying on natural pressure differentials from subslab out to expel the gas away from the home, or it can be activated and become a vacuum basically with an active fan. But really, what our products are doing is not just acting as that soil gas retarder, but because of the performance and the permeance and the engineering and the system approach, not only stopping the diffusive movement of radon, which does have an impact on how it gets into the home, but as that system and sealing and details, that can become a real important part of also helping stop the advective airflow of radon. Right. Because concrete is a good air barrier, right? As long as it doesn't crack, and we got joints and penetrations that have to be sealed, but there's still this potential for diffusion of some radon gas as well, and it doesn't discount the benefits of a thoughtful vapor barrier decision. Yeah.
Makes sense. Let's keep moving.
One of the biggest things that we also run into in the industry, I guess just sort of the code minimums, right? I'm just going to build to code. That's all that I need to do. That's all that the inspectors are looking for. And when it comes to below-slab vapor retarders, for a long time the code has had some prescriptive requirements. 6 mil clear or black, generic poly sheeting. Overlap the joint 6 inches, that's kind of it. One thing I will note is, even within code, it's regardless of climate zone. I mean, there should be some sort of vapor retarder beneath a new slab anywhere we build.
Right.
And that even sometimes is controversial when we talk to builders. They go, no, we don't do that. And
we don't need that here.
I'm still not quite sure how that passes a code inspection, but it does. But the industry is evolving. In the commercial world, for the last 30 years, high performance, thicker, engineered vapor barriers have been the norm. Mm-hmm. We are so far beyond generic poly for the most part in the commercial world. Yeah. I think we're starting to see that evolution happen in residential. It's been maybe a slow, and I think there's a lot of room for education like this.
That's right.
And kind of spreading the understanding. But we're seeing this evolution in code to some degree. This is a snippet of the 2021 residential code. And it basically said, no more 6 mil visqueen, no more regular poly. We need at least 10 mil thick vapor retarder that meets a certain standard, ASTM E1745 in Class A. And we'll talk about why that's such an important standard here in a second.
By the way, your StegoHome 10 mil meets that, right?
Oh yeah. We test all of our barrier solutions to this standard. It's the seminal, industry established, published vapor retarder standard for below slab applications.
Yep.
The code is still in a little bit of a flux, I would say. I mean, wouldn't you say, Brett? It's kind of ebbed and flowed. It's not every jurisdiction, of course, has adopted 2021. And we may see, kind of a change back to 6 mil poly in code. And, there's a lot of things happening in code hearings and how those things happen. But it doesn't negate the fact that really anywhere you look beyond code, even in the residential landscape, there's published guidance for ASTM E1745, which essentially means engineered high performance vapor retarders and barriers beneath slabs. It's coming from the American Concrete Institute. This is their guide for residential concrete construction. Here's one from the EPA about how to build
That's awesome.
healthy, homes and buildings.
Yep.
Yeah, I think there's a difference that happens when you talk about the people who are in the know, who are looking for best practices, who are driving towards trying to solve problems versus having the base minimum from a cost standpoint.
Right.
And so what you saw on the commercial side was there was already a cost with flooring failures that were happening. And so there was an immediate reaction to that, moving from solvent-based to water-based adhesives, because flooring issues were happening in grocery stores and were happening. So owners were pushing back and saying, hey, why is this happening now when it wasn't happening before?
Right.
So that made the standard more important to make sure that we have a product that is specific for the application of preventing moisture vapor from creating a dew point situation, creating a high pH situation that can cause problems with those water-based adhesives. So you had this kind of obvious pain point on the commercial side that you didn't necessarily have on the residential side. And also you had people driving heavy equipment over on the commercial side. So they needed the durability and strength to get through the installation time frame.
Right.
But what gets you in the long run is actually the thing you don't see, which is the permeance and the longevity of the material, making sure that protection membrane and layer is there for the life of the building.
Yeah, that's right.
This last one is maybe a little cumbersome to read, but it's echoing an important point, which is if you start following or looking at even flooring warranties and flooring requirements from manufacturers, even they would say, no more poly, no more regular generic poly at least. We need higher performance membranes. So it gets a little scary when you start thinking about checking a code box. That code is essentially asking builders to potentially void their flooring warranty on day one. And that's why, there's a lot of room for a mindset shift and for action still in the industry to help drive things forward.
And we do have a lot of jurisdictions because of 2021 code where they have adopted this higher level. And so we're seeing that change happen all over the place.
Matt, anything else, commentary you want to provide on some of the impacts to builder from a builder perspective?
Yeah, I mean, I talked about that briefly, but that time of mine in the Pacific Northwest where I dealt with moldy, disgusting vented crawl spaces, and then seeing, the problems throughout Texas, including class action lawsuits against builders, homeowners that are worried about the health of their children. I mean, this is such a no-brainer to not go with code and go beyond code. And not only that, do the best practices, like you mentioned, Brett. Like, just because code specifies a product doesn't mean you're going to install it right, correct? And so that's why this makes a really big difference. And ultimately, for me, I care very much about my reputation and about building a house that's not going to be a problem, not just for my client, but for the client that buys from them 2 years from now that I have no relationship with. Because when they find a problem, they may or may not call me. They may directly call their lawyer. So this is a really big deal, and we've got just one chance to do it.
Yeah.
Another interesting thing about that point of that next buyer is the extensibility of the building and the function that goes on. So that first builder may put carpet down and maybe it's breathable.
That's right.
And the second person comes in and goes, no, I want to have nice luxury vinyl tile. I'm going to put something in that looks good.
I'm going to use this vapor barrier product here, which is going to have a condensation issue.
Yeah. And so suddenly down the road, there's an issue. And it doesn't, whether you were right in the design in the first place or not, if somebody gets pulled back into it, again, it's an impact on business.
Yeah, that's right. Actually want to show this next slide because I hope you don't mind me fast forwarding on there. I think if you're watching this presentation, you should take a screenshot or a picture of this. This slide really makes a difference for me and helps me understand really the value of why we're thinking about this. And to be honest, I've used the thicker Stego on most of my projects. I put that 15 mil in. Maybe this isn't the exact time for it, but just for fun, do me a favor, Bret, and grab that piece of poly right there and tell me if you can damage that poly at all. Like you're a pretty strong dude, but can you put your fingers through that poly? I don't have a knife on me, but take this Stego. That's a 15 right there. That's the more bomber.
This one's a little harder.
This one's a little hard. Now look at this. He cannot put his thumb through that one. Could you put a screwdriver through it? Maybe, right?
You can cut it. You can cut it.
It is puncturable, but it's just so much more bomber. Now that being said, talking through the slide.
Strength is critical. Longevity under the slab is critical, and just maintaining integrity. But probably the most important attribute and thing we're looking for in an effective below-slab vapor barrier is what it's designed to do. Its ability to impede, stop as much as we can water vapor from coming through it. And this is just, there's some caveats to this infographic, but it basically is showing us when you think about water vapor movement through and the potential for dew point to be reached and condensation, this is the amount of liquid water spread out over, in this case, a 1,500 square foot footprint, so, typical size of a new home build. That's what we're talking about every year.
That's amazing.
Coming into, through, and potentially accumulating and condensing in the concrete slab.
Yeah.
So, by comparison, going from 15 mil StegoHome to just generic poly, you're looking at 30 times better permeance, something like that, 30 times less moisture, and with no vapor barrier at all and just relying on a concrete slab. It's scary,
When I saw this slide, I thought that all three of those, 15, 10, and generic poly would be listed as a zero perm product. But in fact, that is not the case.
All may start as class 1, and I think in the residential world, and maybe, dare I say, in the building science world, there's a thought process that if it's class 1 and it's poly, it's a vapor barrier. It's good. The lower the permeance, the better. And we can engineer films now as an industry that combine both strength and longevity and an even lower permeance than class 1. And what we'll talk about in a second here is it's not just the permeance when you buy it off the shelf and roll it on the
and do it in a test lab.
It's about how well does it maintain its ability to slow down or stop water vapor over the life of the home, hopefully. And that's really where you see some noticeable differences as well.
Post-installed vapor permeance, right? After it's been stepped on, after it's been job site messed with, and now we've got a slab on top, and now it's exposed to all the things that the ground bring to that poly over time, that generic poly that we really don't know how much recycled content is in it, what's it like. It's got variance in temperature, it may have liquid water exposed to it, all kinds of different things, such that when we see slabs that have generic poly, anytime we do some demo on those, it's like barely there after a couple decades in the ground.
It's a harsh environment, and it's a different environment than your vapor barrier or not in a wall.
Yeah, that's right.
So this slide is just showing you some of the details of this industry standard, ASTM E1745. Again, published industry standard. It does require a minimum level of permeance. 0.1 is kind of the baseline threshold for the standard, but it also has strength requirements or strength testing. So tensile strength, puncture resistance. There's some optional push-through testing that we do as well. Things that simulate, what we're going to experience on a job site.
Yeah.
But where it really stands out, in my opinion, is the conditioning testing. And you hit it on the head. Under a slab or even in a crawl space, plastic films are going to go through years and years, decades of wetting and drying, temperature changes, exposure to soil organisms.
Right.
This standard, because it's written specifically and explicitly for below slab vapor retarders, it makes sure and puts materials through the testing that ensures that they maintain a level of permeance, effective permeance, for the life of the home. And that ultimately is, some of the big differences between again, higher performance engineered films that are designed to meet that standard in generic commodity plastic.
Yep.
Use it for a million different things, 6 mil poly. It's just not made really to go under a concrete slab.
Yeah, that's right.
A big difference is just that it's the same recipe every single time. It's the same resin base every single time. We're expecting the same performance. It will be rejected if it doesn't have the same performance.
Right.
Whereas when you look at generic plastic, generic plastic in that situation, it just depends on the recycling content is and where that's coming from, and it might change over time.
Sure.
And so there's a much wider variance of not only the strength characteristics, but also the longevity and exposure to some of the conditions that Tom brought up.
Yep, that's right.
It may be obvious to a lot of your audience. It may be obvious to experienced builders, some of the, the obvious problems with generic poly in terms of strength. It doesn't take much to
damage.
Put it on a job site, and
Yeah.
especially if you're, concrete operations and slab pours, those get pretty robust.
Oh yeah.
But we set out to do some additional testing, just so we could kind of understand a little bit more about the problems with poly. And there's kind of 3 tests that I was going to walk through quickly. This first one was just looking at off-the-shelf, new piece of poly, 6 and 10 mil. If you just went to any building supply center and bought a roll,
Yep.
what would that look like in terms of strength testing per the standard? Could it ever meet 1745? And the answer is no, not consistently and not likely. This is just showing a comparison here to our couple of our films, our water vapor design barriers, StegoWrap and StegoHome. Big difference in especially puncture resistance.
Yeah, that's right.
And that's why you see generic poly have those tears and rips and damage on site.
Tom, I'm going to speed us up just a hair because we've got like 30 questions. People have been really jiving on our stuff here, so we want to keep going.
Let me just knock these out real quick. This is also looking at the long-term or the permeance of regular poly, and we looked at both. Again, new material, kind of off the shelf, and also this might be more impactful, real world. But this is showing when you put it through conditioning testing, it does not take long to actually see and experience visual
Degradation.
holes and degradation.
Yeah.
And that again that's just within the lab.
Yeah, that's crazy.
And to the
2 weeks exposure.
to the tune of within a couple weeks, the water vapor permeance is 3 times above the industry baseline that's required for below slab applications.
That's crazy.
It's even worse in the real world. So here's a project that we worked on.
This is from the Reisinger build.
This is the Reisinger build. So example of pulling real poly beneath an existing slab.
Yep.
We went back to our lab and did 1745 testing for permeance. It was
Pretty bad.
there was holes, damage. I mean, small, but enough that it still led to the permeance, the net permeance across the surface area of the membrane, well beyond any sort of reasonable and acceptable tolerance in this application.
Yeah,
So
that's right.
we talked about the impact. Again, the mindset shift. This is an important control layer, environmental separation just at the first side of the home that can have some real impacts on all the things that, hopefully any builder, but especially high performance builders are going for.
Yeah, that's right.
Best news of all, maybe, is we're talking about pennies a square foot.
Yeah.
In material cost and installation. I mean, I don't know if it's an exaggeration to say it might be one of the lowest building envelope products or high performance products. But
So tell me about this estimate of $250 that you're throwing on there. Is that from going from a standard 6 mil poly to a 10 mil StegoHome, let's say, on a typical 1,500 square foot project?
That's exactly what it is.
Yeah.
Yeah. So hundreds of dollars a home.
Yeah, it's not that
the
much
cost
money.
of going to a grocery store run.
Yep.
Bump up to 15 mil, you're probably looking at 10 cents a square foot more, something like that. That's the cost difference, but still, pennies.
Yeah.
Installation, if you're going to go and do a kind of a full standard compliant installation, you're talking about some material costs for that and some care, but pennies again.
Yeah.
So
Yeah, that's right. Let's switch gears and talk about our demo here, because we actually have a full-size demo that we've got prepped for a Build Show Live presentation with Travis Brungart coming up. And so let me walk you guys through what we got here, and then I'll have Tom kind of talk us through the details. What you're seeing here, actually, slide over just a sec, Tom. This is meant to mock up a foundation wall, so full in-ground foundation. Here's your foundation wall. This is your footer down below there. This is your crushed gravel. Then insulation layer. This happens to be some Comfort Board R12. And now talk us through, Tom, what we're seeing on top, this green product here.
So this is our StegoHome wrap. It's the performance that the industry has come to love and trust with Stego wrap, but in a roll size and weight that's a little more conducive and designed, we think, for a lot of single-family home.
What is the roll size on this, by the way, Tom?
So that 15 mil comes in a 12 by 50, 600 square feet. We've got a number of different sizes.
It's pretty tough, right? Grab that roll for me over there, will you, Bret? Just so people can see the roll size.
So if you're used to Stego wrap, it's 7'4",
Giant rolls.
150 pounds. I mean,
yeah, so this is a lot more friendly to the job site, right? What does this thing weigh?
about 50 pounds.
Yeah, not too bad. Not too bad. We could move this around on the job site a little easier.
Yeah,
on a
you know,
residential
for a
job.
typical residential crew, it might be a little provide some ease and maybe even reduce waste depending on the job size. And you know, from a shipping standpoint, it allows us to have even some more channels for this to become available for builders and customers too.
Now, one of the questions we had from somebody earlier was, what's the difference between StegoHome, let's say 10 or 15 mil, and the yellow Stego that's the commercial version? Is there any difference?
Performance, again, is the same performance that the industry loves and trusts with Stego wrap, but yeah, the roll sizing.
It's basically a packaging difference is ultimately what it is, right?
Yeah, and the sizing, again, may reduce waste for some project sizes, but yeah, in terms of performance, it's the same kind of level of high performance.
Another question that I saw coming from someone was, hey, do we put that on top or below the insulation? I know how I'd answer that, but what do you normally say when people ask that?
As a vapor barrier manufacturer, we don't have a strict requirement. We typically see it just like this, above the insulation. Now, a lot of different considerations, but for the most part, we see it done this way for a few primary reasons. One, ACI likes to see the slab of the vapor barrier directly and in contact with the slab. It helps prevent, if you had it the other way, in certain types of insulation, or if you had insulation, even XPS that wasn't taped, you might get what we would see or call a blotter layer, where free water in the concrete could actually flow into that area and eventually come back and cause some problems.
Yeah, you can basically get concrete in between your sheets and then it floats up like a raft.
So iceberging is what,
iceberging,
exactly.
there you go.
So
which you don't want.
Yeah, typically see it done this way. I don't know if you got any extra commentary you want to put on that, but that's
it's really, for me, it's really ultimately boils down to job site ease of use. We don't want that concrete getting in here and rafting that or iceberging that up. And then also, frankly, it's really easy to see and make sure I got all the details right now. I know, hey, the guys taped it because I can see it, right? We've got a 6-inch overlap requirement. So this piece here has been overlapped by 6 inches. And then we're used to seeing the red tape on the job site in years past. This is the same version, except it's branded for StegoHome, correct?
Branded for StegoHome, so it goes with the StegoHome lineup and sized shorter roll length to, again, be conducive to the roll sizing of this lineup. And, in a lot of cases, could reduce the waste you might have.
And this is, like we said earlier, this is that same tough commercial version that we've seen in the past.
Same formulation,
That's right. And then this is kind of a neat product. This is called Concrete Claw. And what you're looking at here is a roll of tape on one side, but this top side's kind of rough. Walk me through what this is for, Tom.
Yeah, so this is a sealing tape that almost acts like a Velcro for new wet concrete placed against it. So you would apply this tape at the terminating edge of your Stego system. Usually, if you had like we don't show it here, but a perimeter wood form. Where you're wrapping the barrier up. And you don't have a wall to seal it to with something like that. You could apply this tape, and once you place that concrete, the mud gets cast into the texture of the tape. you've created essentially a mechanical bond.
It
between
Velcros up to it.
your slab and
Yeah.
your barrier. Yeah.
That's pretty cool. This is one of my favorite products. This is called Stego's Tack Tape. And it looks like this is with the packaging. But what you're seeing here is a kind of like a double-sided tape. This has 2 release layers, 1 on either side. And here's where you're going to use it. This Stego right here is going to bond to my concrete wall by putting this up. Now we removed the 1 release layer, stuck it to the concrete, and now I'm going to pull the 2nd release layer, and now this is going to get bonded to the concrete. And then by the way, best practice is to grab that black tape scraper, and then once that goes down, best practice is use that black tape scraper to make sure we've got good adhesion. And we snapped a line where the concrete's going. It's gonna be a little hard to tell on camera, but basically this is, let's say, a 4-inch basement slab. We snapped a line at 4 inches. We kept our StegoHome at 4 inches or below. So now when we cast our concrete, this will all be below grade. You won't see that. But of course, if something were to come up, if my underwear came up out of my pants, it's okay because my shirt's coming later. My insulation's gonna cover that later.
Yeah, and ultimately, again, in terms of this not being the most crazy thing, it's you're creating a monolithic layer to isolate the home from the stuff in the ground. And these details at the perimeter or even sealing around penetrations, not just water vapor, but these can become critical when you start thinking about soil gas mitigation, radon mitigation.
Yeah, that's
These
right.
are the weak points of a typical installation.
Great point.
And so having these types of more robust options for sealing, and also just the mindset of taking a little more time and thoughtful approach to these details,
Grab
that
me the white one, Brett.
becomes even more critical when you start thinking about soil gases.
Yep. Now, if this was a basement, or pardon me, if this was a crawl space, we also have the same product in white that's intended for crawl space use. So this white one, StegoCrawl, comes in a 10 and a 15 mil. You also have a slightly thinner version, a 6 mil on this one. And you've got all the white tapes that go with that.
Yep.
And we've also got term bar. Like if this weren't gonna get a concrete slab on it and this white membrane was gonna be exposed for the life of the building, that's when I, as a builder, go, I probably should opt for the 15 mil. Especially if I've got, let's say, equipment down there or someone's going to be crawling in that space in the future, I want that really thick bomber one. And then also have term bar, which is a fancy way of saying a way to attach that to our concrete wall with a term bar, not just tape. So you guys have really thought about all the accessories. I think that's one of the things I really appreciate about Stego, is not just a bomber vapor barrier, but all the ways to install it correctly and make sure that it doesn't get penetrated and that I'm doing the details correctly.
The accessories over time, we've been doing this for a long time, most of them have been developed because of contractor feedback.
Yeah.
So people saying, hey, how do we deal with this detail? How do we seal around this perimeter or this foundation type? Yep. And so it's really something when we can listen to what our customers are trying to deal with so that they can do a better job on site.
Yeah, that's right. Let's switch to Q&A, guys. We're at 55 minutes or so. We've gone a little longer. There's so much to talk about here. We're probably not going to answer everybody's Q&A, so if you're on the live, by the way, the Stego people behind the scenes are going to get all your Q&A. They've got your email address. They'll be able to get a hold of you and actually make sure that every single question that you answered is going to get answered in the future, even if we don't do it live. But let me hit a couple questions that I've got here. First off, Mark, a builder from Chicago, has one for you, Tom. I've been using the yellow Stego wrap for years. What's the difference between the green and yellow? We kind of answered this already, but give it to us again, Tom.
Yeah, again, the performance the industry trusts and loves with Stego wrap, you get with StegoHome, but roll sizing and weights, that might just offer some ease of use, ease of installation, maybe even some reduced waste when you've got smaller residential footprints.
Yeah, that makes sense. Tom, I got another question for you.
Okay.
My local code just calls for regular 6 mil poly, but I see that Stego comes in 10, 15, even a 20 mil for some of those options. How do I know which thickness makes sense for my project?
Well, let me start by saying there's some reason we typically started at that thickness. ACI guidelines have kind of put a 10 mil thickness benchmark as their recommendation. So it makes a lot of sense to kind of make that the starting point for a lot of these brands. How do you know which one to use? Enter a budget and performance analysis that builders can do. We can help assist in some of the pros and cons. A lot of builders end up going with 15 mil, not just for that added strength and robustness, as you pointed out, but a lower permeance. So 15 mil StegoHome gets you to a level of 0.01 perms, which again, going back to
super low
ACI guidelines, they would recommend that if you're going to install moisture-sensitive floors,
right.
which is a lot of different types of floors. So
yeah, that's right.
Our biggest seller is 15 mil, even at that.
It's not that much more expensive.
Yeah.
Yes, the most architecturally specified product in the country is our 15
right?
mil product, and the basis behind it would be you want something below your slab that is less permeable than anything you're going to put over the top, coatings, coverings, so you don't have a buildup of humidity in between that can create that dew point situation underneath your flooring.
Yeah, great.
So it gives you that flexibility.
I like it. One more for you, Tom. Do holes in the vapor barrier really matter? Even if it's just the size of a pinprick, do I really need to be concerned about it, especially if I'm not in a radon risk zone?
Okay. There's some good news here about water vapor diffusion. Is a few sporadic small holes in your below slab vapor barrier going to be, a
Catastrophic.
catastrophic
right.
issue?
No.
No, not in reality.
Yeah.
Now, a lot of little holes, even if they take up a small surface area, can, and I think we've shown with some of our testing, or at least reinforced, have an impact on the permeance across the membrane.
Yep.
And so we should have care. We should take the time to repair holes if there are any, and try to avoid putting non-permanent stakes and things like that through the material. But there's a realistic viewpoint here, especially when you've got that concrete slab and things like that.
Yeah.
As a system, a few holes is not going to be the end of times for your project, most likely.
Yeah, that's right. And by the way, we didn't even get to it, but you guys have a whole line of mastics as well as tapes.
Yeah.
So there's a lot of ways to fix those on the job that are really not that hard to do.
What I will mention, though, again, stakes get a little bit higher when you start thinking about soil gases and the way
Good
that those move, also through the advect of airflow, and in crawl spaces too. I know we're kind of been sprinkling in crawl spaces, but when you've got a crawl space, and especially if you've got soil gas concerns, the barrier becomes the control layer. You don't have the concrete slab to also provide your air barrier, utility.
Yeah. Here's one for me. Matt, you've been on a lot of job sites and seen what happens when builders cut corners under the slab. What's the biggest mistake you see out there when it comes to vapor barriers? Then I mentioned it at the top of the hour. In Texas, it's extremely common to see beams cut out at the base of the beam, at the bottom of the beam. We've got to stop doing that. We've got to have a continuous vapor barrier. That's probably the biggest thing. But then I think next on that list is letting the concrete sub dictate what gets used on the job. If you're a builder, if you're an architect, if you're a homeowner, frankly, we need to buck up sometimes and say, hey, this is the right product and I want you to do this. And sometimes you'll find, and I think this is probably true from one of the very first times I used Stego, maybe 2 decades ago now, that my sub after doing it was like, oh, that wasn't that bad. Actually, I really like this. I'm going to start recommending this. This wasn't that hard. I thought this was going to be a big problem. I thought this was, this 15 mil product feels like it'd be really a pain to use, but it really wasn't that bad. And I think the other thing now that is different than 10, 15 years ago is instead of these giant rolls that we had to buy in the past, we've got these more residential sized rolls. So it's one of the things I like about what Stego has done. They said, hey, same bomber products, the StegoHome, as the regular commercial Stego that's in your stadium that was built around the corner for the NFL team. But now it's sized and appropriate for residential job sites. What did I miss, guys? We need to move on. We had a lot of other great questions. I'm sorry we couldn't get all those, but the Stego peeps will get to those. Tell me if someone in the audience has a question they didn't ask or they're watching this later. I've found that Stego has a lot of good people that I can ask questions to. How can people get a hold of you guys?
We care about our customers. We want feedback. You can go to our website. We've got all sorts of information and details and and product knowledge that you can nerd out on if you want to, or you can reach out to us very easily, and we'll get somebody who's local, who's right around where you are, and that's the best way to.
Is there a
get in touch
contact
with
form
us.
on the website, Bret?
Yes.
Okay.
Yeah. So you just go on. You can take a look at where in your region, or you can just reach out to us. Either way, through email, you can ask questions on our site. You can download guides on our site. So try and make it as easy as possible. We try and be very available and just easy to work with.
Yeah. You guys have been great. You guys have been longtime Build Show partners. So guys, really appreciate you all joining us for this webinar. In the future, sign up in the description below for our newsletter so you'll know when we have live webinars so we can get your question answered on the live Q&A as well. With that being said, guys, follow us on Facebook or Instagram. Otherwise, we'll see you next time on the Build Show webinar.